All right. Hello. Welcome to your first real unit of chemistry. So we've talked about the scientific method. Now we're going to talk about matter. Everything we deal with as chemists and chemistry students, we deal with matter. So matter is anything that has mass and takes up space. So everything from you being in this room, in the room you're in, to the particles that are floating around you. So the oxygen you breathe in is matter because it has a mass and it takes up space. You look at the periodic table, you have several numbers, you have the atomic number, and then you have the atomic mass. So your mass number actually tells you the weight of what a particle or what an atom of that specific element is. So if it has a weight, no matter how small or no matter how large, it is matter or a mass, not a weight. So classifying matter. So if you look at all these things, different things have different substances. So it is still matter. So if it is Coke, it's still matter. If it's water, if it's popcorn, if it's gold, different matter have different classifications. So we have what we call elements, so your periodic table of elements, you have mixtures, and you have compounds. So a pure substance is either a element or a compound. So elements are something that are composed of only one atom. So they are the simplest form of matter. You cannot get any smaller without changing the chemical aspect of that element. So if you take the parts of an atom, the parts of an atom are not unique to the substance if you split them apart. So the whole thing is the smallest you can get without splitting a substance apart is an atom. So the smallest you can get to your body is an atom of a carbon molecule, or a hydrogen molecule, or a nitrogen molecule. So this, what we can do under ordinary lab conditions, now we can get to protons, neutrons, and electrons, but electrons are freely moving, but that's for later on. These are the building blocks of all other matter. So you cannot see, so you can't see the gold without millions and billions of atoms being combined together. Same thing, your cells will not exist without the millions of atoms that come together to create your cells. And we build upon it. So you'll find out in biology, you go from atoms all the way to organisms. So atoms to cells, cells are atoms to molecules, molecules to cells, cells to tissue, tissues to organs, organ systems, and then body. So elements, 92 are found in nature and over 109 exist. If you see our current periodic table, we have 118 technically on there. But they are changing every day and they're not necessarily 100% proven yet that these are heavy elements. So examples are sodium, chlorine, hydrogen, oxygen, and silicon. So your diatomic molecules. Diatomic means that in nature they are found paired together. So paired means that you have two as a subscript. So subscript is what you see that is the small letter below it, a small number below it, not letter. But so your seven that we will discuss are bromine gas, iodine gas, nitrogen gas, chlorine gas, hydrogen gas, oxygen gas, and fluorine gas. So remember that. BRINCLHHO and F. Those are your seven diatomic elements that we will discuss. You need to memorize these because later on it will be easier to remember how to write our different chemical equations. All right, so like I said, there are different types. So let me see. So let's fix this for you so you can actually see it. So compounds are a new substance. So you take elements and you combine them chemically, and now we have compounds. So compounds are consisting of molecules. So it's more than one element put together. So you see in your example, you have H, H, and O. We know this as H2O or water. So that is our chemical compound for water. You have 2 hydrogen atoms for every 1 oxygen atom. That creates your molecule. So individual components lose their identity. So now you no longer have hydrogen gas and oxygen gas. You have potentially liquid water. And this is what creates our completely new substance. So H2O, table salt, which is NaCl, sodium chloride, baking soda, methane, nitric oxide. As you go through these will be some of the more common ones that we go with. All right, so that is the last of your pure substances. So pure substances consist of either elements or molecules because that is the smallest they can get. Once you split the molecules of a compound, they become elements. They're no longer molecules. So mixtures. Mixtures are composed of two or more different materials combined. So like trail mix, it's called a mix. It is a mixture. It is easy to see. Hold on. I will fix this real quick. Remind me not to do this in the middle of my presentation next time. It'll be fun. So mixtures are composed of 2 or more different uh, particles, and whether that is a trail mix or a soda, they are different mixtures based on their components. They do not lose their identity. You can still taste the individual components of a soda, even though you can't see the sugar or the water. You can still taste the liquid, and you can still taste the carbon dioxide that is in it, but you can't see it, even though it is still a mixture. Physically combined means they can be physically separated. So it is possible to filter out the sugars, the color, the carbon dioxide from a soda. So we have 2 kinds. We have solutions, which are homogeneous. Homogeneous meaning the same throughout. They have uniform characteristics. So a soda would be an example of that. A salt water, most of the time, would be an example of that as well. And then we have the solutions that are, we talked about solubility this week a little bit in our lab. So solubility, it has to have 2 parts. So that creates a solution. You have a solvent and a solute. So your solvent is your substance that is dissolving your solute. Solute is the substance that is being dissolved. So a solution strength is expressed in molarity, and molarity we'll discuss later on. So molarity is what we have to do. So it is, so the higher the molarity, the stronger the solution is. So jelly, salt water, air, gas, sodas, or glass, not gas. So if we know the solution slash homogeneous mixture is a homogeneous meaning same throughout, heterogeneous means different throughout. So there's not uniform. So Italian dressing, if you look at, so for instance, in Iraq, song, you can take out the different parts of a song, but it's still a mixture of sound. So think about your pure substances as elements and compounds. Your mixtures are going to be either heterogeneous, meaning they are going to be different throughout, or homogeneous, meaning that they are a solution. Remember, solution and homogeneous are basically the same thing. All right? Good luck.